All right, everybody, I just wanted to go over the notes. This is acceleration. And let's see, acceleration is the rate at which velocity changes. So that's the big takeaway. That's the main thing we're supposed to learn, right? This is the formula for acceleration, which we're going to do harder calculations next time. This time we're doing this basic formula. A equals the change in velocity or the change in time. We'll get into the units of acceleration down here. Let's see. The units of acceleration. Acceleration tells you how many meters per second your velocity changes in each second. So this is important to know, and we're going to look at what exactly that means, and that'll be on the homework we're doing as well. So here's an example. A car is initially at rest. 10 seconds later, it is moving at 30 meters per second. So what's the acceleration, right? So remember, acceleration is the change in velocity over the change in time. So you take your final velocity, which is 30, minus what you started at. It started at rest, right? So that's why it's 0. 10 seconds later, right? So that means 10 seconds elapsed. So we started 0 seconds, and then we got to 10 seconds, right? So 30 divided by 10 is 3. The units are meters per second divided by seconds, which is meters per second squared. So this will, things like this will be on the quiz. What are the units? So make sure your numbers and your homework problems, they all have a number and a unit. Now here's what acceleration is. An acceleration of 3 meters per second squared means that 3 meters per second is added to the velocity each second. Okay, so I put the seconds on the bottom here. So here we see each second going by and increasing. So each second we're adding 3 because that's an acceleration, right? So first we started 0, and then it accelerated 3 meters per second each second. So we get 3. And then now it's going to go faster. 6, 9. We add 3 each time. Right, so that's an acceleration. A constant velocity would just be like 3 the whole way through, right? No change in velocity. So acceleration, we have a change in velocity. In this case, it's a change of 3 meters per second every second. So that means every second that goes by, you add 3. So not too hard, right? Then we get into like negatives and positives. Let's look at that. Yeah, signs of acceleration. Let's see here. Signs of acceleration. Positive acceleration of 4 meters per second square adds 4 meters per second of velocity each second that goes by. So here we could see the top is velocity and the bottom is acceleration. So we have these arrows. So we see a constant acceleration. It's the same arrow every second that goes by, but the velocity we see increasing. So this ball that's moving along is increasing in speed because it has a positive acceleration. So what does it mean when you have a negative acceleration? Let's look at that. Negative acceleration. All right, so this one says a negative acceleration of negative 4 meters per second squared adds a negative 4 meters per second of velocity each second. So it starts off going fast, 60 meters per second, but then he has a negative acceleration. A negative acceleration is like putting on your brakes, right? So this guy's got his brakes on, and he's got a negative 4 each second that goes by. So 16, then a second goes by. Minus 4 is 12. Another second goes by. Minus 4 is 8. Another second goes by. Minus 4 is 4. Another second goes by, and he stops. So that's why a negative acceleration is like putting on the brakes. A positive acceleration is speeding up. So that's the difference between a positive acceleration and a negative acceleration. All right, then we have this graph here. What does acceleration look like on a graph? So we're going to start doing some stuff like this with our labs and such. Maybe not till we get back from Christmas break. I'm not really sure. We'll see how it goes. But this is acceleration on a velocity versus time. So here we have different velocities. Here we have time. So as time goes on, what's happening. So here's section 1. The car moves at a constant speed of 3 meters per second for 3 seconds. Okay, so for 3 seconds, he goes 3 meters per second, right? Constant velocity. Then, this is section 2. The car accelerates to 6 meters per second over the next 3 seconds. So then it takes 3 seconds to accelerate to 6 meters per second. Then stage 3, the car continues at 6 meters per second for 3 seconds. So we have flat, angled, and flat. So here we see a constant velocity. Here we see a constant velocity. Here we see changing velocity. And that's all here. Right. And the last thing we're supposed to learn is just that slope is the change in velocity or change in time. So the slope of this line is an acceleration. So this all ties back to algebra, right? And looking at rates and slopes. A slope is a rate. Acceleration is a rate, right? Because it's changing the rate of velocity. And then the last part of the notes, let's see. We got the formula. So here we're getting the slope of this line. 6 meters per second minus 3 meters per second. So that's the final minus the initial over how many seconds it took to do that. That's the acceleration. And then this is just some stuff to recognize when you're looking at certain graphs. So the position versus time graph curves upward like a smile. So acceleration looks like a smile on a position versus time. But on a velocity versus time, acceleration looks like a straight line. So that's a difference here. These are both accelerations, but on a velocity versus time, we see a straight line. On a position versus time, we see a curved line. All right, and then negative acceleration. If your velocity is decreasing, you'll have a negative acceleration, and then that is a negative curve on a position versus time. Because why? Because position is coming back down, and it's slowing down too. Yeah, because on a position versus time, if you have a straight line, that means you have a constant acceleration, but acceleration is changing, right? Changing the velocity. See, changing velocity, right? So these both show acceleration. Yeah, so read up on that, take the notes, read over this stuff, make it look nice, and turn these in.